We're gonna program the fixture plate earlier. So we go to our CAN tab, create a new job. In the job, we're going to want to pick from the cylinder, and then you're going to pick a radius for it to revolve around. Any of the main radiuses will work. Then we're going to click the use stock radius button and just tell it the radius that our stock size is, which is 5 inches. Then we're going to scroll down. We don't want any extra on top or bottom, so we'll put 0 on the top and bottom offset. We're going to pick the top face that we want our z-axis to point in the direction of, and we're going to make sure that that little box under it's on the top center. And then we're going to hit adaptive clearing. Go to our tool library, new mill tool, flat mill, 1/2 inch. Okay, select. Rotate it around so you can see what the hell you're doing. So we're going to step it over 50 thousandths, just like the other one that we calculated in HSM. We're stepping down. I think this is 600,000, something like that. We're going to uncheck the machine cavities because we want the machine on the outside. And we're going to leave 0 stock on the bottom and let the machines all the way down, but we're leaving 20 thousandths on the side. Click the check mark. It's going to generate. We ain't put the feeds and speeds in yet. It's like the other one, I think we were running 7,500 RPM, 120 inches a minute. So now we're going to draw that circle because we forgot to do that extrude. So we just draw a circle on the face of it, starting from the center, and then we'll dimension it 699, which is 10 thousandths under the 7 inches that the other side is supposed to be. We'll do an extrude cut. We'll tell it how deep we want it to go. Check that flip sides or whatever it is so that it's extruding on the outside instead of extruding the inside out and just leaving the thin wall. We want to extrude the thin wall and leave the bulk of it. So then we'll just regenerate our adaptive clearance so it'll pick up that new feature, I guess you'd call it. And then we'll go to contour. Use the same end mill, even though we've got a finishing mill in the machine. Just create a different tool number. Pick the bottom line, check mark. Sometimes you got to go back in, edit it, and hit reverse, especially on these contour operations. They like to, about 50% of the time, doesn't matter whether it's an external or internal. Do another contour operation. Pick the second, the bottom of the second step or upper step. Go ahead and hit reverse and then check mark before you ever even close that one, since you already know what it's doing. And we're going to do another contour operation. Gonna make us a tool, so we'll go to the tool library, new tool, going with the chamfer mill. 1/4 inch, 10,000 nose radius. Okay, select, zoom into the chamfer, pick the bottom of the chamfer, and gotta reverse it. Now we're going to create a drilling operation. I'm doing it backwards, but I'll change it. So I'm going to go to new mill tool. Half-inch drill. For our speeds and feeds calculator, high speed still drill, 1/2 inch, 2 flutes, put in the tool stick out, yada yada yada, hit enter. It's going to give you your RPM and your feeds up there in the right hand corner, and that slider that I just dialed back, the S is speed, the F is feed, you know, so I don't want to be breaking tools, so I'm dialing the feed back some. And then I just go back into the tool and plug that number in. And I can do that for all these tools, but I just wanted to give you an example how it works. I also got an app on my phone that I use, you know, if I don't have access to the computer. That's HSN Advisor that you're looking at there. I got Machinist Cal Pro 2 on my phone. So we just picked the feature from the feature tree, and it already, you know, that's all we had to pick for all those holes was that single feature, since we created them all at one time. Again, you know, I always run into problems when I just try to get it to go through a hole, so I typically just pick a face, tell it how deep to go. You want the drill point to come out the bottom. We're doing chip break and partial retract. Now I noticed something don't look right there, you know, because it shows you the line, the green and red line and stuff like that. So I'm gonna drop that tool in a simulation to see if it doesn't look like it's coming out the bottom, and of course it's not. Because my retarded behind, when I picked the bottom face and told it how deep to go, I forgot to put the negative sign. So it was going 200 thousandths above the bottom face, and I was wanting it to go 200 thousandths below the bottom face, or whatever number I got down there. I can't see the screen doing the voice over. So now we can see that it's actually sticking out the bottom. Now we really did that backwards. Should have center drilled or spot drilled or whatever. So since there was some conversation on spot drilling and center drilling on the machine Facebook page, I'm going to show you the benefit of a 90-degree spot drill. So tip angle 90 degrees. Spot drill has to be bigger than your biggest size, so we're going with, I think I put 5/8 in there. Select that. Now I was hoping I was just going to be able to pick all the holes like I did the last time, but it didn't work out for me because I chamfered all of them. at one time, so it was wanting to take all of them to the same depth. I think that's what it was doing. You know, I try to pick the chamfer on, just the chamfer. I'm picking just the chamfer. Since they all got chamfered at one time, it wasn't going to work. So instead I'm using from chamfer diameter, and then I'm telling it the diameter of the chamfer, and then it calculates the diameter of the tool, the depth, you know, from the diameter of the tool to the diameter of the chamfer. And since it's a 90-degree tool, it's going to be half the chamfer diameter will be your depth. If you need a 100 thousandths chamfer, you're going to go 50 thousandths deep. Now we're just going to duplicate that operation, which didn't really matter. You didn't need to necessarily duplicate it, but and then you go in and edit it. I guess it just keeps you from going and picking the tool and all that crap there. And if you had the feeds and speeds already set, it would already be in there. So now you'll right click in that box, clear selection. We're going to pick that chamfer, and then we're going to click the same diameter button, and then that'll automatically all the same diameter holes, it'll go in that same operation. And we'll do the same thing here. Chamfer diameter. So your center drilling and your chamfering all in one operation. Now we're going to do our tap drill size. So we're going to create another new tool, drill. Type in the size. I don't know what the hell it is off the top of my head. I have to go look at my wall chart. We'll do the math. And then here we can just pick all the holes because we're drilling. And again, we're going to go from selection, pick the bottom face. Give it an offset to get the tip diameter through. Pick a chip breaking again. Well, probably already picked. And now we're going to do a tapping cycle. Go back to library, new tool. Go to the drop down, pick right hand tap. Tell it the size of the tap. And tell it the pitch of the tap. So if you're using a 7/16 14, it's going to be 1 divided by 14. That's your pitch. You're going to go to the feeds and speeds. On a tapping operation, you can only change either the feed or the speed. You can't change both, and they have to be synchronized. So once it knows the pitch diameter, it's gonna. I mean, you can make it run 5,000 RPM, but the feed is going to be in correlation with that 5,000 RPM. Do the same thing, tell it pick how deep we want to go, and keep in mind, if you're trying to make a tap all the way through that part, you're going to have to go a lot deeper than you think. You know, I'm going like 400 thousandths deep, but you know, you probably want to measure the taper angle on the bottom of your tap. Now we'll go back to simulate the whole thing. You can see the stock outline blow up out there, so we'll do stock simulation. Hit that little button, not the last button, but the one next to that, and it will fast forward to the next operation. On here, I just fast forward it all together. So go back to the beginning, start again, hit that button right there that I'm clicking, and it will fast forward to the next operation, and then stop, and you can hit play. So if you just edited an operation and you wanted to see what it was going to look like, you could fast forward through all the operations up to the one you're trying to view. So this would be your first contour. This would be your second contour. I think I'm going to have to flip those contours up and down. I tried to go and leave more material and it didn't work. Just the chamfer on the top of that part right there. And this is where I go back in, I'm editing it, trying to leave more stock. I'm leaving more stock on the adaptive, you know, hoping that it's going to leave stock, not leave those marks. But what I'm gonna have to do is do the top contour and then do the bottom contour. Is the only thing I can think. Simulate it. And fast forward through the first operation, get it done. See, so I wanted to look at this contour, so I fast forwarded through that long roughing operation. Well, it's not long, but you know what I mean. And you see that change I made didn't make a bit of fucking difference. You know, and why should it, right? It doesn't make any sense that it would have made any difference. Whatever. Here goes the chamfer. You see it leaving the old purple on there, let you know that it's cutting. Goes a spot drill. And notice we're going to use the same size spot drill on all of them to do the center drilling and chamfering at the same time. Now we're doing a 1/2 inch drill. Tap drill. Excuse me. And tap. You also can't stop I don't know about all machines, but you can't stop a Hoss in the middle of a tap cycle. You know, most cycles, you hit that stop button and it's going, well, I mean, I guess you could e-stop it, but you can't do a feed hold in the middle of a tap cycle. It's going to finish that tap and then it'll feed hold once it cools out.